All right. So we talked about that the mapper generates key and value. It writes to the context, the key and value. But here we are giving string as the key and long as the value. Okay. And a reducer is nothing but, summing up all the values for a key. And in the driver, we are tying together the whole logic. It's kind of entry point. It's kind of entry point. And then we are exporting the jar, or we can say ant build, and then that should do job. Now, these are the test cases, okay? Now, sometimes you want to implement your own data types. Instead, you are not happy with the text, int writable or long writable. There are many inbuilt. Sometimes you don't want to have your own, you don't want to use the existing one. For example, let us say there is a customer object that you want to give as the key because you want to carry more data, because you need that extra data while computing reduce or while doing the other jobs in the pipeline. So here you might need to carry some extra data along with the key. In those cases, what you do is you define your class and implement writable method. What does writable do? Using writable, you convert your object into array of characters. Okay, so you basically write two methods. One, how to convert your object into array of characters, or you can say array of bytes.
Okay.
Second, given a array of bytes, how to form your object. These are the two things you need to do. Okay, this is called serialization, deserialization. So you have to define your serializer and deserializer. Okay, so which means if you are defining your custom key, let us say in the key, instead of only the word, you have to give out first word as well as second word, for example. Okay, then you will have to define your object, which will have two variables, first word and second word. And then this object will also extend the writable class and implement these two methods, correct?
Okay. Yeah.
And now, keeping this aside, now let me go through another idea, very important one. All right. Sometimes, so far, what we have understood is the key on which we are key on which we are ordering data. The values are not ordered. Okay. A big question generally people ask is, fine, our data gets ordered by key, that we understand, right? Group by and key, ordered by key. So what if we want to order the values as well? Okay, let us say there are 1 million values that are coming for a key, right? And these values we want to order. So how we go about it? Okay, so the technique is that you order by something and group by something else. Okay, so let me try to explain again, right? So let us say there were first word and second word. Okay, Sandeep Giri, Sandeep say Kushwaha, and say Sandeep G. Now, let us say there are such million entries. There are 1 million entries. Okay, and the same is true for, let's say we are designing the happy birthday case. There'll be happy birthday, happy anniversary. Okay, and say and so on, right? Now here there could be another scenario. Then so in the same problem where we are forming first word and second word, okay, where we are breaking down a sentence into tuples, right? Key
Yes.
and value. So we are saying this is a very happy birthday to say Pankaj. Okay. Now, if we are, we want to find out who are the words following each word. So what we have to do is we have to form this kind of scenario, right? This is a and a very very happy, correct? So that out of the whole text, we would know individual key and their values. We will know that what are the words following. We will be able to bring together all the values, all the words following every word. We'll be able to bring together all the words following each word. Correct?
Correct.
Now, question is that when it gets together, imagine the plight of the keys, imagine the situation of the keys such as a. Okay,
Mm.
keys like a would have how too few values or too many values?
Too many.
Too many, right? Too
Yeah.
many values. Now, the way we were thinking earlier is, okay, fine, we will do the grouping, and in the, let's say, imagine in case of happy, we will get happy followed by birthday, birthday, or say happy marriage and happy birthday again marriage. Okay, and we will say and again say birthday. So if you see, if we have to compute the frequencies of these words, we will have to sort it again, correct?
Correct.
Because sorting is the best way of performing the word count, as we have studied earlier, on a larger scale, right?
Yeah. You're right.
Now, if we try to do it in reducer, we will have to do it in memory, and we are not really utilizing the MapReduce. Therefore, that's where the secondary sorting comes into play. Secondary sorting allows us to order the values, okay? Which means this birthday will come together here, okay? And once we have, let's say, ordered, it's very easy to compute the frequencies, correct?
Correct.
And all right, just after here it will come. Okay, so if you have ordered this kind of order, you will read first word. If second word and first words are same, that means increase the count and keep going until the word changes. And the moment your word changes, you print out the total count of the previous one and move on to the next word, right?
Right. Okay.
So the idea is that in this case of next word, previous word, the one of the challenges that we were facing was that if the values are too many, computing the counts will be very difficult, and therefore we want to order the values together, okay?
Okay.
And we want to order the values together. So that's where there's the idea of secondary sorting coming along. All right. So let's say there was a mapper. Mapper gives primary so mapper would, okay. So so the way we are all going to order the values is by implementing the primary and secondary sorting. And how do we do that? We form a key, okay? We form a key which is composite of primary word and secondary word, okay? We let Hadoop order the data first by the first word, then for the same word, it will order the data by the second word, all right? So we form the key which is composite of two words, okay? And then we define an ordering in which it orders the keys by first and second words, and afterwards, turn off my phone. Okay, so we are asking Hadoop to order our data by first word and second word. So our idea is we will make a key which is composite of happy birthday, happy Diwali, happy. So each word is going to be a key. Each tuple is going to be a key. And when we define tuple, we will have to define our own serialization and so on. And we will tell Hadoop that, hey, sort by first word and second word, but group only by first word. You got my point?
Yeah, got it.
All right. So this is our mapper gives out primary and secondary key. There is a maybe a partitioning happening. Then we'll have to define our partitioner such that it partitions based on only the key, not key and the value. Okay. Because if it partitions some data based on key and value both, what would happen is for some keys the values will go here, some keys the values will go here. Okay, same keys. So we don't want to split the data based on both key and the value. We want to split the data only based on the key, so that all values for a key remain on the same reducer. All right. And after partitioning, the grouping will happen, and after grouping, the reducer will happen. All right. So the idea is create a class. Okay, create a class which is composite. Okay, and then you define a comparator, which is grouping and partitioner. Let me open the code. That will give you a bigger idea. Or let me give you the screen control. That will be even easier. Okay. And let me, were you able to see my screen? Yeah.
Yes.
Let me, how do I, okay. Stop video. Okay, how do I stop share? Okay, now you can share the screen and I'll walk you through. Till now, the idea is clear, right? All we are trying to do is sort by primary and secondary, and then group by only the primary key. Okay,
Yeah.
you can quit from your column queue. Quit. Yeah. Yes. So go up. And cd dot dot and
Okay.
next word. Cd dot dot slash next word. And vi asterisk. Okay, so you can see that we are defining a grouping comparator. Okay, and notice this, that we are only comparing the primary key of the two, pk. Okay, and I'll just go next, colon next. Okay. Okay, say capital R, recover, enter, yeah, next. Ouch, there's something wrong with it. All right, let me show my screen. I think that'll be better. Okay. I'll just directly open my GitHub repository, and that should be good. Okay, so here in the SRC, we have next word, and in the next word you have let me explain to you. The first most important class is two words. Okay, what does this two word do? It defines a new data type for the key. Instead of using the text as the data type for our output key of the mapper, in which we were only giving one word, here we define the two words, which is composite of which is which is composite of first word and second word. See, there are two words in this. All right, And we have also created a blank constructor in which there are nothing, and then we have also created another constructor in which you pass the the two words, first word and second word. All right. We've also defined a method called toString, and we have also defined two more methods: get primary key, get secondary key. Although these four methods are not of much significance, okay, they are of not much significance. That is just a convenience for ourselves. You will see what do I mean. These are just extra methods. These are not really required. Maybe you would require it. You could also say get first word, get second word, just to access these two words. These are public methods, and since our two words are private, that's why we need a way to access it from outside. Okay.
Okay.
And now, the important methods in this are: one, how to convert a binary stream using how to convert a binary stream into the object. So this input stream called in we have methods called read string. So we tell this stream that just give me a string, and that's how we prepare our two strings out of the binary data. So this is how you deserialize. Next is writing the this second method. The formatting is a little off here. There should have been two tabs here. Now, this write method, we explain to the system the data out, that first convert first word, then second word to the binary data. That's it. Okay. So this way we do the serialization and deserialization. This is deserialization, this is serialization. Okay. Now, so we defined our object with two variables. We define a constructor. We define a toString method, not of much use. It's just for, when you try to print this two word, then this is what will come into play. Not much of a significance. More important is, the next important thing is this compare to. Okay. When we are comparing these two objects, we are first comparing by first word. You see, first word, we are comparing first word with the arguments first word. Okay. If you compare the current object with some other object, how should it be ordered? How should it be compared? So we first compared the first word, then second word, and we return the result. Okay, this compare to method is inbuilt in the string method. So we are using this comparison between the two words. So this compare to, if you had used in say C or C# as well, compare to between the two strings will give us a number between +1, 0, and -1. Okay, it will be either negative, positive, or 0. Okay, so if it is 0, that means first word of both the tuples, or two words, there'll be, because this two words is getting compared against another instance of two words. So if first word of both is same, then result will be 0, and in that case the second word will be compared. Okay, and the output will be returned. If it is not same, the same result is going to get be returned, which means if either of the words differ, then result will be non-zero. If they are same, then result will be 0. Okay. And so we define compared to, first we created the toWords class, which is composite of key and value. We defined a way to save to the data input stream, and read from data input stream, and we define a compare method, correct? So this method is going to be used in sorting. Okay, and for grouping, we are going to define another class. Okay. So here we are going to define something called grouping comparator, and take a look at it. Here we are only comparing the first part. Okay, we are only comparing the first word, not the second word. You see, PK was first word, basically the extra method which we had defined. because this next word comparator is outside the class, therefore it can't access the first word, second word. It can only access the public methods. Therefore, get pk method we are using here. Okay, so here we are accessing the private the first primary key pk first word, and that's all. We are comparing only this. So effectively, using two words comparator, we are ordering data by first word as well as second word. While using the grouping comparator, we will be only grouping the data based on the key, not the value. Okay, now let's take a look at the driver. Here we are saying that our mapper class is this mapper, reducer is this. We'll take a look at reducer also, and we are also adding input path. Now let's go up what we wanted to show you. This is the only extra thing which we are defining. We are not defining the sort comparator. If let's say there was an external class which you want to impose as the comparison, instead of defining the compare to method in the two words class, right now we have defined a compare to method in two words class. That is what is used by default. Okay, the keys, every string has a way to compare with another string. That is used by default. Similarly, we have defined compare to method on our object so that it can compare against other keys, and that is what is being used. If you don't want to use that and you come up tomorrow with some other external function, you can define your own comparator kind of class and plug it in using set sort comparator. Right now, sorting is happening because of two words comparator function. Right?
Right.
Now, we are using external grouping comparator. If we do not use this, what would happen is that grouping will also happen based on the way sorting is happening, which means first word and second word. So some of the first words will go on one machine, some of the first word will go on another, because if you don't say that sort the data based, group the data based on only the first word. If we comment out this piece of code, then the grouping, that the results will be disastrous. Okay. Now, so group, we have defined how to sort, we have defined how to group, and now I'm going to show you what are we going in the reducer, what we are doing in the reducer. Now take a look at it. Okay, so what exactly are we trying to do here? We are going from left to right. Okay.
Okay.
So this is the result which we are getting here. Okay, so let's say anniversary and so on. Okay, so what we are trying to do in this, so as I was telling you, the grouping will happen on the first word. All the values will come out as ordered, right?
Yeah.
So this values that you see here contain all these the words. And also take a look at the mapper once more. Okay, I'll go back to the mapper. Here we are giving the two words. Okay, we are creating two words. So first we took the words, right? Whole array of the words. Then what we said was, for each word in the words, record the previous word. Okay, if previous word is null, then record it and go back to the next word. So for the first time we are going to skip it. Then second time, previous word and current word we are forming the tuples with, and then we are writing the output. Okay,
Okay.
is this clear to you? Now here notice that the key is the two words, while value is only the second word. Make sense to you?
Yeah.
All right. Now, all right. So yes, now take a look at this. Here we are iterating only on the second word, because values are what? Values are what? The current word running. Okay,
Yes.
and the key is tuples. Okay, Okay, so key is tuples and value is second word. And now also we could have actually capped the two words itself in the key as well as values, but there was no need. Okay, because we have to just group all the values. Now what we are trying to do is iterate over this list, go from left to right. Okay, birthday, 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 Diwali, marriage, marriage, anniversary. Anniversary will be in the beginning because the data will be ordered. Okay,
Okay.
it'll be like this: anniversary, anniversary, birthday, birthday. I know the spelling mistake. Okay, now if the previous is null, which means there was nothing, we are here, there was nothing between because we are starting. So if we have previous, so we record the previous, increase, set the running count to 1. Okay, which means we have only encountered anniversary as 1, and then set the previous word as anniversary, then we go back to the beginning of the loop. Okay, then again we come here, we read the next word, and then we compare. Previous is null? No, because previous is this one right now. Because every time we have to check whether this current word is different from the previous or not. Therefore, we have to record the previous word in this array, in the running one. In case, if previous word equals the current word, running count we increase. So anniversary, since it's same as previous word, so running count has become 2, and then we again continue from the beginning. We go back here, then we will encounter, say, birthday this time, which means previous is not null because previous is anniversary. And we, and it's not equal, therefore it won't go back to the beginning, and this time it will create this tuple, the word and the running count. Okay, so what we are trying to do here is we are basically keeping a record of the word and the running count. Okay, and it's nothing but like a hash table we are maintaining, that since anniversary has finished, anniversary is not going to come again here. Okay, anniversary is not going to come again here, therefore we write this to the output saying anniversary has occurred twice. The same thing will happen birthday for the first time, since it's different from the previous one. It's different from previous one. You can see is okay. So if because we are here, right? So running count, previous word will get replaced with birthday this time. Okay, and running count is reset to 1 again. Okay, and then again the same loop will come and birthday will become 3 and it will print. All right, and this one is only for the case where we have finished the list till here. Okay, so previous word is marriage right now and we encounter the list has ended, which means this marriage will go unaccounted. Therefore, we have put one more clause after the loop, because loop has finished and we have not printed the sum of so far accumulated marriage here. And for that, we are having this particular clause after, which is same as this one, you see, which is same as this one.
Yeah, got it.
Just for the last one. Now, yeah. Now what we are doing is whatever we have accumulated so far in the PQ, this is add to the list PQ. So whatever we have accumulated so far in PQ, we iterate over it, we empty it, and put it in the context. That's all. Okay.
Okay.
So we basically print anniversary to. So what we are trying to do again, we are going through this list. Okay, I'll tell you what do I mean. Yeah, this is another function. So here the main problem, we forgot the actual problem agenda we had. We wanted to keep only top 5. Okay,
Yes.
we wanted to keep only top 5. So every time we encounter a count, we push it to a list. So we encountered anniversary 2. Okay, so so we encountered anniversary 2
Mm,
and birthday
3.
3 and Diwali 1. Okay, So let's say we are just counting top 3 for time being. Top 3. So far, top 3 are these. And the moment marriage comes into play, marriage 2, which means it has to knock out this one,
Yeah.
right? So we
Yeah.
only have to take care of top 3, not the whole list. Otherwise, it will overflow our memory, right?
Right.
If we try to count everything. So for that, I have written this small piece of code somewhere. It's called priority queue. Okay, I haven't done it. So here is the priority queue. Okay, so in the priority queue, we are basically pushing the data. Okay, and in the priority queue, we basically put the data in the form like actual word and the running count. Okay, so we have created our class called WC tuple, and we are pushing into the priority queue. What is priority queue? It's a heap. Okay, so uh, if we have to count, we have to keep only top n numbers anytime. Okay, so we'll have to keep removing all of this, right? The way we just did.
Right.
And tomorrow, if something else comes up, let's say happy Holi or happy Christmas, and that's 10, that means it has to knock out the Diwali, marriage one, right?
Right.
Either you could maintain your own algorithm or your own list, sorted list, in which you keep on counting and do this, or you write your own piece of code where you iterate over your top n items all the time. Or you could use a standard way called heap. Study about priority key and heap. Okay, so heap equals kind of the equivalent data structure for heap is priority key. In the computer science, we generally read it min heap, max heap kind of thing. Okay, and in Java, we emulate the same thing using priority key
Right.
queue. And it's a very important interview questions as well, that if there are a running number vote count happening, okay, and you know that the data is coming in the sorted way, what is the easiest way to keep track of the top 3 winners? Okay, so in those cases, you generally say that you maintain a max heap, sorry, min heap, and uh, basically min heap makes it possible to knock out the minimum or the maximum very easily. Okay, min heap allows you to knock out from the list. Hello.
Hello.
Ew, something has happened.
Yeah.
Where was I? What was I
You
describing?
just started that voting one, the example.
Yeah. So yes. So min heap is gives us minimum very quickly. Max heap gives us maximum very quickly. Because and take a look at these data structures called min heap or max heap or priority queue. So we are using priority queue to knock out the lowest frequency one with the recent one. Okay.
Okay.
So that's what we are trying to do here. We are using basically this standard data structure called priority queue. We are putting the object and this priority, and it'll give us the so whenever we are adding to the list, it'll basically give us that value. All right. So that's a that's a easier way to how should I? But I'm wondering, I have not defined the way to knock it out. Okay.
Sandeep, I cannot see the screen.
Oh, sorry. Okay. So yeah, here if you define in priority queue a way to knock out this latest the all right. So up to here it's clear, right? That we are pushing it to priority queue. We are
Right.
utilizing priority queue to maintain a ordered list of things while we are adding things in random. Okay.
So the in the priority queue in this declaration, we are using the WC tuple.
Right.
So this.
Oh, I got it. I got it. You know what? I'll tell you. So this method called add to list, right, is our method.
Okay.
Oh, you come again. I think I wrongly understood your question.
So just wanted to ask what exactly that this using the WC tuple here.
Yeah. So whenever we use priority queue, we have to define our own object.
Okay.
Okay.
Yeah.
So we have to tell priority queue that on what priority, on what function, what variable will serve as a priority in this queue.
Mm.
Okay.
Okay.
So I'll show you. So let me just go back to WC tuple. Okay. So here is the WC tuple. It has two things. One is the word happy, for example, and count. What is
Mm.
the frequency? Okay. And here we are comparing the two words. Here the comparison is happening based on the counts, meaning which one is more frequent.
More
Okay,
frequent. Okay. Yeah.
whether happy or married, and based on this we are ordering the data in the priority queue. And this function called add to list is what we have created. Here we are saying that if size is lesser than 5, keep on adding. And the moment you reach, if size is greater than or equal to 5, that means from the top 5 billboards so far, we have to remove the weakest one and put the one which is, if the newer one, a newer word, say we encountered here, say Diwali, sorry, marriage, which was better than Diwali, so it has to remove that. That's what we say. Peak. Take a look at the one which is the least frequent. Okay, and this one, when we say peak, take a look at the least frequent, because priority queue makes sure that at the top it remains the least frequent one. And how does it know that? Based on this function. Okay, so priority queue gives us the one which is the lowest one, and we take a look at it, and then we basically check here that if the lowest one is lesser than current one, remove it and add the new one. Okay, remove the lowest one and
Yes.
add the new one, and otherwise don't do anything. If so far the count, that the one which is at the top means in the priority queue, if you have ordered this way, the top means the one which is least frequency. And if that one is weaker than the current one, that means we have to remove that and add ours. Okay, so why I have done it again, I'll explain to you once more. So again, why so many optimizations? One, the values for some of the words could go into billions. Okay,
Yeah.
the words like the, in, of, etc., the values could go into the millions. Therefore, we needed an optimized way of sorting, of first sorting that data. Second, computing the frequency out of sorted data. Instead of loading the whole data into memory, we computed the running count and running top n. It's a very important algorithm, and people do ask this frequently. Compute top n elements in a running count, specifically in running data. All right.
Yeah. Okay.
So do I make sense to you?
Yeah.
All right. All
So
right.
Sandeep, in the last that WC tuple code,
Hmm.
that there was a function that to compare that you were mentioning.
Yes.
So where exactly we are calling that?
Yes. So internally, priority queue will call that function.
Okay.
So it's a kind of contract that if you define, you have to define compare to function, and you have to mark it override,
Mm.
because this is comparable. We are saying WC is a comparable class, and we are defining this. Now, when we hand over something, to, let's say, priority queue. Okay, so when we hand over something to priority queue like this, we tell that whatever we add here, when we
Mhm.
add something to priority queue, we are adding here using wc.add_to_list method. So inside this, we are going to add our word, and this priority queue automatically will cast it to word comparable, and comparable class, and we'll use it internally. So this is a way in Java we define interfaces. They are like contracts, and all those people who want to use my functionality, they have to implement this interface and provide whatever I demand. So queue demands that we define compare to method. Okay.
Okay.
So a priority queue demands that we define a way to compare the objects, and on that basis, priority queue will form the queue which is in certain order, and we will be using that. Did I make sense? No.
Yeah, that's good.
Okay. So this way we have efficiently did couple of things. One, mainly we did a very important part in all of this is computing the running count, running top n records of humongous data. This is something I have seen some people's MTech project and PhD projects, and all of the people try to do this tuple word count, first word, second word kind of problem, frequency computation. We call it n tuple problem, n tuple. Okay, they
Okay.
try to use tools like R. They try to use tools like Java, and since these kind of problems can only make sense if the data is humongous, right? Because imagine that if you have this say couple of MB data and you are trying to compute first word, second word, happy birthday and all, the result will not be that impressive. But if you do it over gigabytes of data, hundreds of gigabytes of data, or say even say 10 gigabyte of data, it will start making sense. Okay, because bigger the number, better the results. But if you see 10 gigabyte is too much, if you think about loading it into the memory using Java or anything, because 10 gigabyte might quickly become 20 gigabyte, because first word, second word, this kind of data structure. So 10 gigabyte will actually become 50 gigabyte, because you create the data structures that generally take 5 times the actual data, and effectively cannot you cannot use the what do you say effectively you cannot use those classic methods like R, Java, or anything on bigger data, and therefore we had to use MapReduce. And MapReduce is one such solution in these cases where which can scale well, which can go up to hundreds of gigabytes without any issue. All right, so I hope that was clear.
Yeah, good.
Okay, okay. Any other questions at this point?
No, I'm good
All
with
right.
this.
Okay, great. All right. So that was my, way of explaining it. Feel free to let me know if you have any other questions. All right.
Yeah, I'm good with this. So the session was recorded, so I will go it again
Okay.
with
Okay.
all these things. And other thing that I wanted to ask, that to run this next word thing, that I need to create the build.xml, right? First,
No, it is already created. I think it is created. Let me check.
but that is only for the
Uh,
word count one.
yeah, yeah. I'll explain. So I'll tell you some here. So see, when we say build, it basically is bundling everything which is there in SRC. Okay,
Yes.
it's
Okay.
just a matter of calling it using a different driver. Okay,
Okay.
it's just a matter of calling it with saying, what is the package? Next word dot ND driver. So if we call it using say Hadoop jar, whatever is the jar name, extra jar, okay, and then we say next word dot ND driver. Okay, and then you provide the input directory here. Okay, my input and my output. Okay, so instead of extra jar, I'll just say it properly. So this is what we do here. So just you have to change the driver in the argument, because the code is anyway bundled. The whole code is anyway bundled in the same MapReduce. Okay.
And the input file. So which data I can use as an input for this one?
This one I have not prepared any input per se. You can download some data from here or there, or you could use the same one as that. You remember
Oh,
data/mr/word count,
yeah,
just for the heck of it. Okay,
yeah.
you could use this. All right, so you could use this as well. I think this should do. Let me. I'll check if it is working, and then. All right, so try this one, and this should do. All right. Any other questions at this point, Pankaj?
No, I'm good at this point. Thank
Okay.
you.
Okay.
So, Sandeep, can you these notes? Can you send me the link?
Okay. Okay. These notes, yes. Let me. Okay. Let me save these notes. All right. These are 1 on 1 6 October 1 on 1 Pankaj 6 October. Okay. I'll share this. All right. Okay. So I hope the session was useful to you. Do you have
Yeah,
any other questions for me?
it was really good session. So, a few things that I think I might need to discuss with you again if I don't understand them properly.
Okay.
But overall, the session was good, and I really appreciate that you gave that much time to me.
All right, great, 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 Pankaj. I'm really happy that it made sense to you, because this is quite little advanced. So I was avoiding this discussion in the class, and it's only for those people who are really interested in MapReduce, because somehow most of the MapReduce people have removed from their what do you say, the curriculum, although it's very important. But the same thing could be also done in, say, Spark or other things. So I have avoided this discussion because it's not required by many people.
So, in
Al-
that the companies and industry, how much they are using the MapReduce nowadays?
So right now, lots of people are actually using MapReduce. Okay, just that not everyone is able to utilize MapReduce to a full extent. Okay, but people are using, and forming a MapReduce code is little tricky for lots of people. That's why not many people are very successful. Okay. And even this problem, say first word, next word, only a few candidates have been able to do it so far. And but good news is that even that the alternatives like Spark and all are kind of more user friendly with respect to these things. Okay, they're more direct rather than indirect, because there is always this question: who is executing my mapper, who is executing this, so that kind of confusion is not there in case of Spark. But since MapReduce has been for quite some time, there have been a lot of tooling around MapReduce, and a lot of people are already using in their production. Therefore, there is always a scope of using MapReduce. Second, in certain cases, MapReduce is still a better solution than any other technology, specifically in the cases when data is humongous,
Mhm.
which Spark can't handle. In those cases, people generally fall back to MapReduce. All right.
Okay.
So that was pretty much. Any other question, Pankaj?
No, that's it. Thank you very much, Sandeep.
Okay, okay. See you in the class next week. All
Sure.
right.
Thank you. Bye bye.
Bye. And